Hello. In the last lesson, we created a function for getting the available capabilities for our swap chain. The swap chain is responsible for presenting the frames to the surface. So we need to define certain settings for our swap chain, like whether we want the frames to be RGB, BGR, or just red, or how we want to send frames to the screen. Wait for the image to finish rendering, or directly replace the image currently being rendered, which might result in tearing. Or just have one in a queue and one currently rendering, and discard that one in a queue when we replace it, if we manage to request the render before the current has finished rendering. Or we can have multiple frames in queue waiting to be drawn. And finally, we have to select the size of the frame that we want. This is also known as extent. We'll start by adding a new function called createSwapChain. I will also call this function in the initializeVulkan method. And I scroll above to create the function body. The first thing I do inside this function is get the swap chain properties from the chosen device. We will have to select one surface format out of the list of formats. We also need to select one present mode from the list of present modes. And finally, we need to select the extent of our frames. Now, I will create these functions separately. We start by defining the choseSwapChainSurfaceFormat, which takes a span of formats. Then we create the choseSwapPresentMode, which takes a span of present modes. And finally, we add a choseSwapExtend. Let's now go one by one. If the format size is 1 and the format is equal to the VK format undefined, this means that all formats are supported. In that case, we're going to return a new surface format, KHRStruct, initialized from a VK format, R8, G8, B8, and A8 as norm, and a nonlinear sRGB color space. Otherwise, we will go through the formats. If the format doesn't match, let's return whatever is the first format. And if the format is either RGBA as norm, actually let's choose sRGB as it is more common, and the color space is sRGB nonlinear, then we return that format. Since we want to use a 4-component based RGBA format, we can also create a function that will validate that it is any of the 4-component RGBA types. It will be either this one here, or it could also be BGR-A format. The difference being which color channel is first, between blue and red. We can also create one function that will check if it is the sRGB color space. And to simplify even further, we can just create a new function that will return the combination of both of these functions. We can then use stdefInDef and call the isCorrectFormat function using the begin to end iterator. And if the result is not the end iterator, we can return the reference of that iterator. Now, for the present modes, we would check if the mailbox present mode is present. The mailbox present mode is the most straightforward. You have one frame rendering and one in queue. Again, we can use the findIf to try and see if we have the mailbox supported. If we find it, then super, we can use it. Otherwise, we can return the FIFO, which is similar but is surely supported. The difference in FIFO is that we can have more frames in queue. We can also reformat this to not call findIf but instead call anyOf. This will save us one line. And finally, we need to choose our swap extent. Since the swap chain can be created later, we can check if there is a current extent. If the current extent width or height is the maximum on-site integer value, then we can return that extent. So I will also create a new constant value for the invalid size and assigning it to the std numeric limits max value for unsigned. If it isn't invalid, we can just return that extent. Otherwise, we can get the frame buffer size from the window. And to get the window, we need to have this as a class method. So I will copy these three function calls and go into the graphics header. I paste these functions in the header file and then format them as function signatures. The swap surface and present modes take spans of this data. Now we return to the choose swap extent. I correct this to be a const reference, and we can now use the window get handle to get the frame buffer size into the x and y values. We can also create this function on the window class, as this would be ideal. I will copy the implementation from here, just renaming the value to frame buffer size. And then we also need to call the correct function for getting that size. Again, we return to choose swap extent and we set the size to the new getSize method on the window. We can then initialize the actual extent variable that we will return from the size. And we need to cast those values to unsigned ints. Since the frame buffer can be bigger or smaller than the maximum or minimum extent supported, we will need to clamp the width to be between the min and max extent width. And we need to do the same for the height. Clamp just makes sure that the value is between one of those. If it's lesser or greater, it will just take the limit. Finally, we return the extent. And this is everything we will do in this lesson. We have chosen our format, mode, and extent.